Good morning, class, or afternoon, whatever, evening, whenever you're watching this. Hope that you're doing well. Again, I still miss you. I also just want to give you a little bit of an update with the online learning being extended a little bit. Please be checking your email. I do plan on sending you out an email, just giving you a bit of information on the notes and what I expect from you as far as what to have done, how I'm going to grade you and things like that. So be checking your school email. If you're not sure what that number is, it's your graduation year. So if you're a freshman, it's 23, and then your lunch code number, that 4-digit number, at ms.svbearcats.org. So be looking at that over the next couple days. And I did try a new kind of angle here. Hopefully you can see my screen better, but I did upload the answer key on the at-home assignment. So be looking on there as each lesson goes on for the new key, so you can go back there and see what I wrote on my screen if you didn't catch it on the video. So today we are doing factoring part 2, and so this will become the most important part of factoring. So this is a pretty important lesson. 2nd through 5th period we did this already, but it's not a bad idea to have a refresher because it's the most important part of factoring, basically. So today what we're going to do is factor, and that's the main word there. So factoring is writing a trinomial as a product of two binomials. So a trinomial has 3 terms and a binomial has 2 terms. So the product of 2 binomials, basically what we're doing is we're trying to get some x squared plus bx plus c to look like this, with maybe an x plus a and x plus z, something like that. So we're trying to take this trinomial and make it look like a binomial. Basically what we're doing, what we did the other day, when we multiplied 2 binomial expressions, we got a trinomial as our answer. So what we're going to start doing by factoring is we're doing the reverse of that process. So we're unfoiling or unboxing or unmultiplying, if all of that makes sense. So instead of me giving you these 2 binomial bubbles and saying multiply them, I'm giving you a trinomial, I'm saying factor it. So you need to know, well, what was the first times the first to give me this? What was my outer times my outer to give me this? What was my inner and my inner? And then when they combined, why did they give me this? What's my outer times my outer? Why do I get this? So we'll get into that into more detail, but to start off, we're going to cover the first step of factoring. So there are several steps of factoring, mostly 4 that I'm going to teach you, and this is the first one. So right here where it says AKA, we're going to put unfoiling. My pen loves me. Unfoiling. And then it's also like undistributing. Okay, so we're doing the reverse process of that. All right, so I asked you to recall, factor the number 56. What does it mean if I'm asking you to factor a number? What are factors of a number? It's 2 numbers that multiply to give you 56. So if I'm asking you to factor 56, I want to know every combination of 2 numbers that multiply and give you 56. So what I would recommend doing is always starting with 1 and that number. So what we have are 1 and 56, because 1 times 56 is 56. If you struggle with factoring numbers, what I would recommend doing is just take a calculator, take that number, so 56, and start dividing it by each number, 1, 2, 3, 4, 5, 6, 7, 8. That's because if a number divides without a decimal, then that means that it is a factor, because the opposite of multiplication is division. So if you take 56 and divide it by 2, yes, it's a factor, also because 56 is even. So 2 and 28 are factors of 56. Can you divide 56 by 3 without getting a decimal? No. You get 18.6 repeating. So 3 is not a factor. 56 divided by 4. Yes, you get 4 and 14. Does 56 divide by 5? No, because it does not end in a 5 or a 0. So 56 divided by 6. Nope, decimal. 56 divided by 7. Yes, you get 8. Okay, the next number on the list is 8. Yes, it is a factor of 56. So once you get to the same number, or it starts repeating, then you're done and you have all of the factors of that number. So these are all of the possible factors of 56. 1 and 56, 2 and 28, 4 and 14, 7 and 8. Done. So if I asked you what the first step of factoring was, you should tell me factor out the common monomial. So term there, common monomial. Monomial. Mono meaning one, nomial meaning term, and something that is in common. So like I said, we're going to be looking at trinomials or binomials and factoring them, so unfoiling or undistributing. And a common monomial is something that each term has in common. So I'm asking you, what is the greatest common factor of 120 and 24? So basically I'm asking you, what's the biggest number that you can divide out of 120 and 24? The biggest number that you can divide out of both. So if you have to use a calculator, but if you look at them, you can divide 4 out of both of them. But is there a bigger number? Oh, well, 120 divided by 8. 8 divides out of both of them. But is there a bigger number? So if you keep guessing or keep plugging and chugging, you should find that 120 does divide by 24. So actually 24 is the greatest common factor of 120 and 24, because 120 divided by 24 is 5, and 24 divided by 24 is 1. So 24 is the biggest number that can be divided out of both 120 and 24. And that's what we're going to be doing today. What is the greatest common factor of 91 and 56? So the biggest number you can divide out of 91 and 56. What'd you get? I got 7. Because 91 divided by 7 is 13, and then 56 divided by 7 is 8. You can't divide anything more from 13 and 8, so 7 is our greatest common factor of 91 and 56. Okay, that's the biggest thing you can divide out of each number. So when we're looking at factoring a quadratic expression or any type of polynomial expression, 2x squared plus 9x. So first of all, if you look at the numbers, 2 and 9, is there any number that you can divide out of both 2 and 9? Hopefully you said no. So there's no number that we can divide out of each term or factor out of each term. But if you notice, this first term has x squared. So it has 2 x's, because remember x squared is x times x. And then this second term has 1 x in there as well. So that x is what both of those terms have in common. They each have at least 1 x in them. So that x is what we're factoring out. So basically, factoring out something like a common monomial is like dividing it out. So 2x squared divided by x, this should remind you of what we did in chapter 7. You have like bases, so you can subtract the exponents, or just think you have 2 x's and you're taking 1 out, so you only have 1 x left. So the x that you're factoring out goes out front, and then parentheses to show what you have left. So the 2 stays, and we took out 1 x, so there's only 1 left. Okay, so that's what's remaining in the first term. In the second term, 9x, we're dividing the x out. So all we're left with, that's a plus sign, is a 9. So that would be factoring out the common monomial. Since we're undistributing or unfoiling, what you should be able to do is to redistribute or refoil to check your answer. If I were to multiply x times 2x, would I get 2x squared? Yes. If I were to multiply x times 9, would I get 9x? Yes. So we did it correctly. So that is your final answer there. Okay. If we take a look at example 2, 21w squared minus 15w plus 3. So now we need to look at all three terms and see what's the biggest thing that we can factor out of each term. First of all, look at the numbers. 21, 15, 3. Is there a number that you can divide out of all three of those terms? Hopefully you said 3. You can divide 3 out of each of them. Okay, now look at the variables. W squared, W, no variable. Since this last term does not have a variable, you cannot factor out a variable. They all have to have a variable in order to factor it out. So a common monomial is something that every single term has. Okay, so since this doesn't have any w's to give, you can't take any. So all of the w's stay, and all you're doing is factoring out the numbers. So what you should end up with, 21w squared, if you divide the 3 out, you get 7w squared. Negative 15w, well, if you divide out 3, you get negative 5w. And then plus 3. What's 3 divided by 3? 1. You would not want to put a 0 there. You need that 1. 3 divided by 3 is 1. Because remember, if you redistribute that 3, you need to be able to redistribute to something to get that 3. If you had a 0 there, you would be missing out on that last term. So you need to have that 1 there. And then that's your final answer. Okay, there we go. There we go. All right. Easy as that. Okay, here we go. Let's look at number 3. Okay, look at the numbers. 36, 27, 81. What's the biggest number you can divide out of all of them? So if you need to, use a calculator. 36, 27, 81. 9. Yeah. So you can divide a 9. Next, if you look at the variables, x squared, x, y, x. So even though there's a y tucked in there, what does each term have in common? They each have at least one x. So factor it out. So 9x is your common monomial. So then, showing what's left, what's 36 divided by 9? 4. If you're taking 1x out, how many are left? Just 1. 27 divided by 9 is 3. If you're taking the x out, what's left? Y. And then negative 81 divided by 9? 9. If you're taking the x out, what's left? No variables, just the 9. And there's your finished answer. 9x is your common monomial. You should be able to redistribute and get what you started with. Cool? I'm going to do number 5 with you. You can do number 4 on your own. Okay, number 5 will be kind of similar. So if we look at number 5, 28, 16, and 80. Well, first of all, they're all even, so we should at least be able to divide a 2 out, but check for that biggest common factor. 28, 16, and 80, I'll divide by 4. Is there a bigger number? I don't think so. So 4. Got the highlighter still. All right, now look at the variables. N to the 4th power, n to the 3rd power, n squared. There are 4 n's here, 3 n's here, and 2 n's here. How many n's can you take out of each term? 2. You can take 2 n's out of each term. Okay, they all have 2 n's to give up. So you're also taking n squared, n times n, out of each term. So 4n squared is your common monomial. Now you need to show what's left after you factor that out. Well, 28 divided by 4 is 7. N to the 4th, if you were to divide n squared out, you're taking 2 of those n's away, you're left with n squared. 16 divided by 4 is 4. N cubed, well, you're taking 2 of those n's out, so you only have 1 left. And then minus 80n squared, 80 divided by 4 is 20. And then n squared, you're factoring out the n squared part, so that's all that's left. You can always double check the part inside your bubble, 7n squared plus 4n minus 20, to make sure there wasn't anything else that could be factored out. If you could, that means that there was actually a bigger common monomial at the beginning that you should have factored out. But we're good there. I haven't taught you yet to see if you can factor that any farther, but eventually in the future I will. So this is factoring out the common monomial, something that each term has in common. You're doing example 4 on your own, and then when we come back, the next lesson will be part 3. Factoring trinomials when your leading coefficient is 1. All right, so hopefully that made sense. If you have any questions, email me. Please reach out to me. Don't be afraid to leave a comment and just tell me how you're doing. I miss hearing your guys' stories every day, and I'm really bored. So feel free to shout out, tell me a random fact. Did you get a puppy? I'm about to, maybe. I don't know. Stay tuned for that one. But I hope you have a great day, and I'll see you back for the next lesson. Bye.